So where should the linear inequality be shaded? Above the line, below the line, or neither? Yes, Sean. Below. Do you agree with Sean? What? He said below. Okay. Why do y'all say no? Desmos? Okay, what's another way you could have checked it without using Desmos? Say again? So we could pick a point. We could say 0, 0, right? And we could plug that in. So 0 is greater than or equal to 1/2 times 0 minus 1. Well, what's 1/2 times 0? And 0 minus 1 is -1. Is 0 greater than -1? Yes, it's bigger than -1. So we should have shaded above the line. Okay. Another thing, ready? If you have y is greater than, that's going to be above the line. If you have y is greater than, it's going to be above the line. Does that make sense? Okay. I would either have that memorized or plug in that point. Okay. This is very similar to what your mastery check is going to look like. It's not multiple choice though. Okay. All right. On the next one. Number 2. A family can spend at most $25 at Fun Zone. It costs $10 an hour for trampolines and $5 an hour for the pool. The family can stay less than 4 hours. Select the point that represents a solution. Okay, so what's the answer? A, B, or C? I heard some A's and some C's, so let's check it. If I plot the point 1, 3, that's right here, right? If I plot the point, y'all said C as well, 1.52, that's right here. They both kind of look at like they're in that shaded region. Here's the only problem. You see how there's a dash line here, and then there's a solid line here? That means that it works for one inequality, but does not work for the other. I think I made a mistake with y'all last week when we were talking about this. So if it has a solid line and a dash line, this point right here would not work. Okay, so C is going to be the correct answer. All right, so Jada wants to go to homecoming dance. A ticket costs $75. Jada saved $45 already and earned $10 an hour babysitting her neighbor. Determine the inequality which can be used to find the minimum number of hours Jada needs to babysit in order to pay for her dance ticket. So how much does she already have? And then how much is she making an hour? Okay, and she needs to make at least $75, right? Okay, so the minimum number of hours that she wants to work though. So we want to make up to $75. So they wanted to find the minimum number of hours. That's why we're going to go up to $75. Okay, so which one is that? I don't think it's B. It's C. No, it's not. Look at it again. Oh, okay. They put greater than. I'm sorry. My bad. Because you can make more than $75. Okay. Well, she can make more than $75, but she has to at least work that many hours, right? If you solve that out. Questions over this? Okay, your mastery check is very similar to what number 1 looks like. Okay, how did y'all do on this? How many y'all got 100? How many y'all got 2 out of the 3 questions right? Okay, yeah. How many got 1 out of 3 questions right? Me, yeah. Okay, cool. All right. Okay, so on this one, we want to graph an ordered pair that is a solution to the inequality. Okay, so let's take a look at what some of you might have put. All right, so someone said 0, 2. Would that one work? Yeah. Why does it work? It's in the shaded region, right? What if they picked like a point right here? Would that be an answer? No. Why not? Because it's on the dotted line. Okay. So remember, it's only a solution if it's on a solid line. Go ahead ahead and take a look at slide number 2. Go ahead and find a solution for that one. All right. So on this one, some people said, Mikkel said -2, -2. Would that work? Yeah. What about 0, -1? That would work. Go ahead and go to slide number 3. All right. So do you think that there's an ordered pair that is a solution of both that inequality and the other inequality? Yes. Why? Okay. So where would the answer lie? In the blue, red, or purple region? Purple. In the purple region, right? Exactly. So that's where those two colors overlap. Okay. Another thing to mention is anything on this line would be an answer. This point right here, this guy right here, I need you to pay attention, is not a solution. The reason why is because this guy is dashed, this guy is a straight line. Okay. So you could have put anything in that purple region, okay, because that's where the two shades are crossed over. Okay. All right, so go ahead and just pick 2 ordered pairs and put them on slide number 4. And then go ahead and answer slide number 5. So answer slide 4 and 5. Okay, so what were some ordered pairs? 5, 0. So this right here? 5, 0. Remember, your first term is your x, and then your second term is y. So, huh? 0, 5, that would be up here, right? Are you saying 0, -5? There you go. Okay. So 0, -5 would work. What else would work? Yeah, I feel you. -6. Well, that would be over here, right? Remember that first term is your left and right. 0, -6 would work. Okay. All right. What about 3, 0? Is that going to be a solution? Because why? Because it has a dotted and a solid line. If you don't have a graph, how can you check to see if the ordered pair is a solution? If you don't have a graph, how can you check to see if the ordered pair is a solution? What would you do? Plug it in. So you would take the point, let's say you had this inequality, and let's say you had the point 0, 0. You would plug that in for y and x, and then solve, see if it actually worked. If it worked, great. Now, if it's a system of inequalities, you have to plug it in for both. Does everybody hear that? Like, just because it works on one doesn't mean it works on the other one. So you have to check both. All right, go ahead and try slides 8, 9, and 10. I'm going to give you a couple minutes. Okay, so student council is selling tickets to the winter dance. The tickets cost $5 per person or $8 per couple. To cover expenses, at least $1,200 worth of tickets must be sold. No more than 500 students can fit in the gym. Okay, so X is going to represent the number of $5 tickets. Y is going to represent the number of $8 tickets. And rows 5 and 6, we're going to write this. Let's see what you came up with. All right, I'm going to use this one. So we're going to look at this one. So this person said 5 times X plus 8 times Y is greater than 1,200. Okay, so they needed to sell at least $1,200 worth of tickets. So does that work out? Yeah. What about no more than 500 students can fit in the gym? So why did this person say x plus 2y? Okay. And they said that no more than 500 students can fit, right? Okay, so we had 2 people on 1 ticket in that instance, but there's still 2 people, right? So this is how you would write out that inequality. Okay. Now they also said, so a solution, and this person picked 0, 190. So they could have 0 single people going to the dance, but have 190 couples, right? That would be so sad. No, just me. Okay, cool. Thanks, guys. But that could be a solution. Okay. Okay. So on number 1, it says to find solution and graph it, right? The first thing that we always have to do is put it into y equals mx plus b. So we're going to move that x to the other side by subtracting. And then we're going to divide by -3. And so that's going to give me y. And when we divide by a negative, we're going to flip the symbol. Negative divided by a negative makes a positive 1/3. And 9 divided by -3 is going to give me -3. Okay, so the first thing that you're going to do is put this in y equals mx plus b form. Okay. Yes. 1/3. Because this is -1 right here. And then divide by -3. Yeah. Okay. Now, when you graph this, you're going to take your y-intercept and you're going to plot it. So -3, 3. And this slope is saying go up 1 to the right 3. Okay, so we're going to go up 1 to the right 3. 1, 2, 3. We're going to go up 1 to the right 3. We're going to repeat this going the opposite direction. Down 1 to the left 3. 1, 2, 3. Is this going to be a solid or a dashed line? How do we know? Okay, so it doesn't have that line underneath, so it's going to be a dashed line. Now, how do we know whether or not to shade above or below? You can plug in a point, right? Yep. Say again. If it says y is greater than, then we're going to go up. If it's y less than, then we're going to go down. So this is less than, so we're going to shade below. Yes. Because -1 divided by -3, that's going to give me a positive 1/3. Yeah. Okay. So again, if you don't want to plug in numbers or whatever, you can just memorize this little thing. Okay. Now give me 2 solutions. 2 solutions. So what points would fall in that little realm? We could do 2, -1, 2, 3, 4. So 2, -4. We could do 1, 2, 3, 4. 0, -4. Does everybody see where I'm getting at? You're picking points that are inside that shaded region. Now, non-solutions, that means numbers that, or I'm sorry, things that don't work or things that are not in the shaded region. Give me a point. 0, 0 is not in that point or not in that shaded region. What about 1, 0? Okay. Now, that next question asks you to prove algebraically whether or not the point 3, -2 is a solution. So what you're going to do is you're going to take this inequality and you're going to plug in the point 3, -2 and see if it's a true statement. You can also look at 1, 2, 3, down 2. this point right here, and you can ask yourself, hey, is that a solution or not? But they want us to prove it algebraically. So take a moment, see if you can plug that in. So when I plug in 3, -2, that means I'm going to have -2 is less than 1/3 times 3 minus 3. Well, 1/3 times 3 is 1. And we can keep -2 on this side. This will give me 1 minus 3. 1 minus 3 is -2. So ask yourself, is -2 less than -2? No, they're equal to it, right? But that doesn't have this little symbol right here. So this is not a solution. I remember this being a question on the SAT way back in the day. I wouldn't put it past them to do it again if you're going to take the SAT. I know that's a little far out for y'all, but still. Y'all take the PSAT on like October or something, right? 20th, maybe. Okay, so if you're able to do that, then you should be all right for your mastery check. Okay, so graphing and then saying two solutions and 2 non-solutions. Okay, the graphing is probably the hardest part. Yeah. Okay, let's try one more, and then I'm gonna give you that. Let's do. I said I was gonna do number 6. Yeah, let's do number 6. Okay, go ahead and take a moment and graph this guy, this first one. Okay, and then we have to rewrite this guy in y = mx + b format. But go ahead and take this first one and graph it. Okay, so I'm first going to make sure that this is in y = mx + b form. It is. So now I'm going to put my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then my slope is up 4 over 1. Okay, well, I can't go up this way, so I'm going to go the opposite direction. I'm going to go down 4 over 1. Down 4 over 1. 1, 2, 3, 4. 1, 2, 3, 4. Is this going to be a solid or dash? Solid, how do we know? Line underneath. And are we going to shade above or below? Above. Okay. So let's plot this really quick in Desmos just to check our work. So y is greater than or equal to 4x + 8. And is that above or below the line? It's above. Okay, sorry, I panicked for a second. I was like, did I do that right? Yes, I did. Okay, so we would shade this way, right? Now we're going to graph the other guy. We got to write him in y = mx + b format first. We're going to move that x to the other side. And then we're going to divide by -3. When we divide by -3, that means we're going to flip the sign. And so this is going to give me positive 1/3 x minus 5. So now we're going to plot this guy. So we're going to plot -5 first. And then we're going to plot our slope. So that's up 1 over 3. Up 1 over 3. Up 1 over 3. And repeat that process the other side. One, 2, 3. There we go. Okay. Is this solid or dash? Dash, because there's no line underneath, right? And is this going to be above or below for shaded? Above. Now, here's the thing with the second shading, you want to make sure that you only really dark shade the parts where they cross over. So if I shade above this line, all this junk in here is going to be my true solution. Okay, so the dark shaded region is the solution. Okay,